This is on page 265 to 268, simplifying trig expressions, factoring some trig expressions, distributive property with trig expressions. If you'd like to read in the book on page 265, they highlight a couple things there in regards to some formulas that we're going to use. This first identity, if you remember, is called the Pythagorean identity. Sine squared of u plus cosine squared of u equals 1. Remember, we can rewrite this equation to other forms. So if I were to subtract sine squared of u from both sides, and I solve this for the cosine of u, it looks like 1 minus the sine squared of u. I can also rewrite it where I leave the sine squared of u on the left, and I subtract cosine squared of u. So here are 3 different ways to rewrite that Pythagorean identity. Then we also have below the quotient identity for tangent, where tangent is the sine of theta over the cosine of theta. So let's go on to our first example. We want to simplify this trig expression. We have 3 cosine of theta plus 4 cosine of theta. Think of these as like terms. Cosine of theta and cosine of theta, they're the same trig function, so we can combine them into 1. So we have 3 cosine of theta plus 4 cosine of theta is 7 cosine of theta. Think of it just like if you had 3x plus 4x. 3x plus 4x is 7x. Next example, the tangent of x minus 3 tangent of x. If I throw a 1 there, 1 minus 3 is negative 2. And then tangent of x. Now it's going to go on to ask about factoring. The number 1 rule to factoring is taking out the GCF. So in this first example, we have a GCF of 2. So we're going to divide out or factor out a 2 from this expression. So 2 divided by 2 is 1. I take a 2 out of here, so I'm left with negative sine squared of theta. Now, 2 slides ago, we talked about that Pythagorean identity. Looking at this red Pythagorean identity, 1 minus sine squared of u can replace with cosine squared of u. So we're going to replace this piece with the Pythagorean identity of cosine squared of theta. Let's go down to example B. We have another GCF of the sine of theta. So we will factor out a sine of theta from both terms. So now this sine of theta is gone, so we're left with cosine squared of theta. We take out a sine of theta here, we're left with sine squared of theta. Now in that parentheses, that is the Pythagorean identity again, from right here. It's the top one in the black. Sine squared of u plus cosine squared of u equals 1. So we can replace this parentheses right here with 1. So sine of theta times 1 is just the sine of theta. The last example in this lesson is simplifying the following trig expressions by foiling. Be careful that you do not do this common mistake of distributing in that 2. That's a mistake. We're going to take the cosine of x minus the sine of x times the cosine of x minus the sine of x. And we're going to FOIL first, outside, inside, last. So first, cosine of x times cosine of x is cosine squared of x. Then we go to outside. Cosine of x times negative sine of x is negative cosine of x sine of x. Then, inside, negative sine of x times cosine of x is negative cosine of x sine of x. And then we have our last. negative sine of x times negative sine of x. Negative, negative turns it to a positive. Sine of x times sine of x is sine squared of x. Now what I have is some like terms right here in the middle, in the blue. Negative cosine of x, sine of x, minus negative cosine of x, sine of x, is now negative 2 cosine of x, sine of x. Then I'm going to bring this green sine squared of x to the front. And then I still have my black cosine squared of x. Now look, these two are the Pythagorean identity. Cosine squared of x plus sine squared of x is 1. So I have 1, and then minus 2 cosine of x, sine of x.